All right, guys, I just started recording. I'm doing good, Sean. Thank you for asking. So far today's class is going to be, we're going to go ahead and start chapter 3 today, guys. But before we get into chapter 3, I do want to make an announcement. Monica did send out the information of the department chair for math and the math lab number as well. I am going to resend that as well later because I'm going to be sending out the review for test 1 through email, as well as the link for the lecture once I upload it on YouTube after this class. Um, so a few announcements, guys, a few announcements. So this week, what are we going to be doing? So today we'll be doing starting chapter 3. And then on Wednesday, so we have 4 sections of chapter 3. We have 3.1, 3.2, 3.3, and 3.4. After we have done all those 4 sections, you should have everything you need to be able to complete the exam that we're doing this week. Now, and I'll reiterate this at the end as well, just because some students come on pretty late. So remember, this week we will be taking test 1. Now, I asked my colleagues how they do their test administration. They tell me they do it during class. Like they say, so on Wednesday they would give you out 2 hours and you would take the test. But I really don't like that because this is not traditional. We're in a flex course. You guys have other classes, you guys have jobs, you guys have other responsibilities. So I'm gonna give you some academic freedom. What I'm gonna do is the test you will have a timer on the exam. You'll have 2 hours from the moment you start it, but you'll have until Sunday the 31st to complete the first test. So my recommendations is, class, I recommend have all the notes from all the lectures. So if you've been absent, go on YouTube, watch the lectures that you've missed, copy down the notes, practice the problems, and then go to the homeworks, complete all the homeworks from chapter 1, chapter 2, and chapter 3. I believe it's gonna be a total of 8 assignments you have to do. Once you do all those 8 assignments, and you do I made a review from the test, guys. So if you can do the review on your own, confidently, and you did the homework on your own and got A's,
Is it me or did he just cut out?
and guys should have. Can you guys hear me? Testing, testing. Can you guys hear me?
Yes, sir.
All right. Thank you. Thank you. So yeah, so pretty much, guys, so I'm gonna give you out till Sunday to pretty much finish your homeworks and the test. Now the review, I did make a review, guys, that I'm gonna email after class today, so that way you guys can actually start the review. And like I said, if you can do the review and the homeworks, you should be able to ace your exam. Now, the exams are worth 50% of your grade, so I highly encourage that you guys really do your best and take advantage of the review. It's not mandatory, the review, but I did make one as a extra resource for you guys in this class, which I'll be emailing to you guys after class.
I have a question.
Yes, what's the question?
On the homework, if we got like a bad grade on one of the assignments, but we're doing good in all the other assignments, can we receive tutoring for that?
So yes, if you're stuck on an assignment, like you're not able to do it on your own, the answers are coming out, you need help, yes, you can come to tutoring. Now, remember, there are two avenues there are actually 3 ways to tutor. 1, you can do the brain fuse tutoring through Canvas. 2, you can go to any community college in Alamo, with your student ID, and get free math lab tutoring at the centers, which I'll be sending out the information. And then option 3 would be tutoring sessions with me. Now, you will have to contact me when you're available to see when we can set something up. But it depends on the timing, on when you're available and if I'm available as well. So I recommend you utilize your other resources that are allotted for you, but I am one as well.
We like take the homework assignment, because I don't know like if we could or can't.
Like if you can like do the assignment or redo the assignment, is that what you're saying?
Yes, like if we can get like maybe possibly a higher grade than what we got.
Yeah, so I believe you have 3 attempts per problem. And then if you don't get it right, you can do a similar problem and switch it out for another one. Have you messed with that setting yet, Jennifer, to see if you can redo an assignment or a problem to give you a similar problem?
I did, but I don't know what I'm not getting. On the other assignments, I got like 198, and then this assignment, it like dropped me down so much. I don't know
So
what I'm not getting.
so I guess after this class section, if we have class time after I finish the lecture, you can show me what you're talking about off of your computer screen, so that way I can better help you, if that's okay with you.
Yes, that is.
So and then so now at this point, guys, so I have some questions. So when are the assignments due? I pushed last week's assignments till 31st, so this Sunday. So all the assignments and the tests will be due by Halloween, 31st on Sunday. Now I'm gonna open the exam on Wednesday for you guys to start it from Wednesday till Sunday. Now I'm not gonna tell you when to do it, what day, what time, but the moment you start the exam, you'll have 2 hours. And you will not be able to, let's say like Rosemary's like, I'm gonna get on start my test today because I'm ready. She starts it, someone calls her, hey girl, happy hour. Say, oh, okay, let me pause it real quick. And she goes, I believe, and I may be wrong, right? But because I had my math lab when I was a student too, but that was like years ago. And the timer would keep going. So I wouldn't do that. So I recommend once you start the test, tell
Just
the
finish
world,
it.
yeah, finish it. Tell the world,
Okay.
hey, 2 hours. That's all if you may be done before 2 hours, right? But 2 hours is the maximum. So you want to make sure you have the review done, you have the homeworks done, you have your notes ready because it's open notes, open review. You can use any and all resources for the exam. So
Okay.
did I answer everyone's questions about the exam and the assignments? Okay.
Use notes, or
Go ahead.
we use notes on our exam, or how does that work?
So what that means is, so for example, when you start the test on, let's say Thursday night, you're off, you have no obligations, the kids, or you have the kids with your parents, you have free time, you start the test, you can look at problem one, you can look through your notes to see where I did the example. My biggest thing, the review will be your best friend. Because the review, what I did is I opened up the exam on my computer on Sunday and I typed, excuse me, and I typed questions up that were similar on the test. Does that make sense? I just switched up the numbers and the letters and stuff. You know what I mean?
Yes.
And the test will be open starting Wednesday after class, after I'm done with the lectures. Now for the review, I'm gonna email the review today, and then I'm gonna upload a picture of the answer key on either Tuesday, Wednesday, the latest. So when I send you the review tonight, I recommend, or after class, like this afternoon, I highly recommend all of you guys to pretty much to try to do the review by yourself and then do all the it's 25 questions. So the review is 25 questions and the test is 25 questions. So I recommend you guys do all 25 questions of the review on a separate sheet of paper, do all your work, whatever section is on. So let's say the number one, the review is 1.7. Write 1.7 next to number one. So you know that problem is in that section. So that way, when you do the test and you see a problem on the review, oh, that's like number 4 from the review. Oh, that's 1.8. And then if you need help, you can go to 1.8. Kind of organize yourself, okay? And I'll try to add little notes on the answer key. So the major grade, so the test that you're doing, it is a major grade. It's a test grade. And remember, your test average is 50% worth of your grade. So you want to make sure you get really good test grades, guys. And the first test is the easiest. So it is only gonna get more challenging on forward. Yes, so there is a time limit, guys. The time limit is 2 hours, a 2 hour time limit, like the way you would have for the final. So I'm coaching you guys from these other tests to prep you for the midterm and for the final, because those are 2 hour tests. So
Okay.
that's why the other tests are 2 hours. So that way you can train and coach your mind and body to take 2 hours, no more. Does that make sense, everyone?
Yes.
All right. What other questions do we have based off of what we've been discussing so far? All right. It's very imperative that everyone has my math lab access already at this point, guys. It is very imperative. I've helped students already from the other class get access this morning. If we have class time, I would gladly do so. I believe my math lab allows you to redo assignments for higher grades. So I just need to find a way on how to do that again because I don't know the steps, but I'm sure you should be able to, right? Has anyone got a problem wrong on my math lab and I let you do another one to get the credit back? Right? What do you
Yes.
what do you click on to do that? Is this
Uh, if you get it wrong, you can press similar question and it pops up a new one.
okay, cool. And Jennifer, did you do that on your assignment when you were the one you got a bad grade on and did a new one pop up?
Yes, the thing is like I don't know what I'm doing wrong. I follow the steps. Like I don't know. It was
Oh, okay. So it's just you know you could do it. It's just you're not able to produce the right answer. Is that what that's your issue, right?
yes.
Oh, okay, cool. And I'll gladly be able to help you after the lecture today, if we have the time, okay? And if
Excuse
not,
me.
yes.
On that note, I noticed also, sorry, that it shows you, it gives you different options to learn, like show me an example, get me a tutor, or give me a similar question when it's asking you to help you solve the problem. Are you using that as your to your advantage as well? Because it
On
takes you
one-
step by step.
Yeah, I know. On the ones that I was doing though, is the only option was textbook. And I already have my notes written in just like the textbook, so I was still getting it wrong.
Okay.
Also, and then you know what, Jennifer, I'll take care of you. Don't worry. If it's not today, we'll set up a time tomorrow or Thursday, Friday to set up a meeting. Okay.
Okay.
Thank you for y'all's concerns, guys. And also, if you guys are available, I'm gonna start a discussion post for you guys to upload y'all's information. I really want you guys to try to set up study groups that go to say, hey, who's free on Wednesday night or Thursday to go to my math lab, to go to the math lab at PAC and do homework together. I really want you to utilize each other as a network because that makes a huge difference, everyone. Yes, working by yourself is not too bad itself, but math is a collaborative subject. That's why I'm always asking you guys questions to participate. I'm asking, do you agree or disagree with that? I'm having you guys kind of put yourself out there because that's how math kind of settles for people, is when we talk these ideas out with others. So, all right, guys, let's begin. So we're starting lecture 3. If you guys think of any questions, comments, or concerns regarding my class, assignments, or tests, or review, or anything, just type it into the chat, either directly to me or to the class, and anyone else can type in. I'm noticing people are answering other people's questions, and I love it. So let's get into it, y'all. All right, so today we're gonna start out with chapter 3. So I'm gonna go ahead and give you guys about 2 minutes to set up this slide into your notebook, and then I'll go ahead and discuss it. I'll give y'all 3 minutes. Actually, it's a lot to write, so 3 minutes. Good luck, everyone. I'll see you in 3 minutes. All right, guys. You guys are writing down these notes. I'm going to read them over, and I'll be happy to give any more time for anyone still writing. So 3.1 is simplifying algebraic expressions. So to know what simplifying those expressions are, what is that? What is an algebraic expression? Well, recall that an algebraic expression is pretty much a combination of numbers, letters, which are also variables, and different operating symbols, which is the different operations: addition, subtraction, multiplication, division. Now, note the terms of an expression. Well, first, what is a term, right? Well, a term of an expression is separated by a plus sign or a minus sign. So for every addition and plus sign in the expression, that the things that are separated by the plus sign are considered the terms. Well, before we know about that, let's define what these different terms are. We have two different types of terms. So definition one, constant term. A constant term is pretty much just a term that is a constant or number. So what does that look like, right? So this is just like 7 or -10 or 4 or 2/3 or 1.5. Any number that's just a value, a number. That's what a constant term is. So i.e. a variable term is a term that contains a variable. We know a variable is also a letter. So now let's go ahead and talk a variable term. So what's an example of a variable term? We have 3x is an example, 7y, 8a. Anything with a variable is a variable term. And then we have the third definition, numerical coefficient, the number factor of a variable term. The reason why I'm saying the number factor is because 3x is another way to say 3 times x. So we know x is a variable, and we know 3 is a coefficient. And it's a numerical one because it's a number value. So this and all of this together, this is a variable term. So 3 is a coefficient where x is the variable. And remember, when we have a number next to a letter, they're being multiplied. That's why it says the number factor for the coefficient definition. All right. Does everyone understand the difference in the terms of what's a constant term and what's a variable term? All right. Would anyone need any additional time to finish writing these notes or this slide in their notebook before I move on?
I just need a couple of minutes.
Let me know when you're
Sorry.
good. Let me know when you guys are done. So
Thank you.
Monica and Sean, you just say I'm done so I can move on.
I'm done.
All right, good, good, good. And then Sean, let me know when you're good to go, sir.
He's done.
All right, let's go. All right. So examples of terms. So look over here. Go ahead and give you a minute to write this. So x plus 3, guys. Remember what I said, what separates the terms, right? Pluses and minuses. So and x plus 3, can y'all tell me how many terms you see in this expression here?
2.
Yeah, we have x and we have 3. Now, what kind of term is the x?
Variable.
It's a variable term. And what do we call the 3?
Coefficient.
Now coefficient. It starts with a C though, but it's not coefficient.
Constant term.
A constant term. Good. Now, how many terms do y'all see in the second expression here?
1.
So
2.
2. I heard 1 and 2. Anyone agree, disagree, or have a different idea of how many terms we have here? Remember, what separates a term? A plus and a minus. So look again.
3.
3. We have 3 terms. We have 2 variable terms. And we have 1 constant term. Now you're probably wondering, okay, so we're expanding our knowledge of these expressions. We're learning what makes these expressions the way they are. Now, no, the reason why we're kind of exposing ourselves to the different terminologies of expressions is because of the next component of the lesson. So far, anyone still need more time to write this down before I move on to the next slide? I'm not trying to rush anyone. I just want to make sure everyone has time to write. Last call, anyone need additional time? Okay, let's move on. So the reason why there's matters, so there will be expressions where terms are gonna have like terms. So what is a like term, right? Well, a like term is pretty much they have the same variable factors with different coefficients. That's what a like term is. So look at this box here real quick. Like terms is 3x and negative 4x. They're alike because they both have what letter, guys?
X.
Excellent. Just like in this row, all of these
Y's.
are y's. Now, unlike terms, so but these both have an x. What's different about this 5x and x squared?
They're different they're different variables.
Well, the variables are the same, but it's just one variable has a what? What do we call the 2? It starts with letter E.
Exponent.
It has an exponent. This exponent changes the game. It is an x variable, but this x is being squared. Okay. Now here, this is pretty common sense, but they both have a 7. But the thing that makes them unlike is the what?
The X and the Y.
There you go. So I'm gonna go ahead and give you guys about 2 minutes to set this up into your notebook before we move on. Because there's a concept there's a reasoning behind understanding what like terms are. Because some equations and expressions are going to have them, and your job is to combine them. All right. Anyone need additional time on top of those 2 minutes, guys? All right. No one's all right. Everyone's good to go. Let's see how we're going to apply these concepts together now. So before we go on to the first examples, let's go over a new property. It's called the distributive property, guys. I'm gonna give you about 2.5 minutes to set this up into your notebook. Now there is I also want you to add 2 components. So you notice how it's saying A, B, C are numbers and AC plus BC is equal to this. Well, another way we can write it, and I want you to write both of these ways. So it'll be, you write it this, and then you write or. It's gonna be C parentheses A plus B. It can be in this order as well. They mean the same thing, okay? So I'll give you 2.5 minutes to work on this slide. One second, guys. I gotta go back for a quick second. 1 second. Let me know when you're good to go, Josh. All right, moving back to the property, guys. I'm gonna restart the timer. 2 minutes, starting now.
So if we did all of the homework already, we technically don't have anything to do like tomorrow, right? Since we're not on Zoom.
That's correct, but I am gonna be assigning the homework. So every time we have a lecture and whatever lessons we finish in class, I assign the homework after class.
Okay.
So you'll have 3.1 and 3.2 homework to do today. Not that it's due today, but you'll be able to start working on it today.
Okay.
All right, guys. So real quick, I just want to highlight this property a little bit. So you see how it says AC plus BC equals this. What happens here is that they multiply the C to all the things inside the parentheses. So A times C is just AC. Remember, we wrote a note in last week that said AC is the same thing as A times C. So just keep that in mind when we have two things next to each other, two letters, they're just being multiplied, okay? So that's what distributing means, is that when you distribute something, you're multiplying it to inside the parentheses. And I like to use arrows to denote distributive, so that way, or distribution, so that way we don't get confused with the steps that we're doing. So let's move on. So before we go into applying the distributive property, we're gonna go ahead and work on simplifying expression by combining like terms. I'm gonna go ahead and give you guys a minute to set up this slide before I begin working it out. All right, so now let's look at this. So example 1A, simplify each expression by combining like terms. So the combining is pretty straightforward. It's just pretty much what's the operation. And remember, the things that separate the terms are pluses and minuses. So depending what's separating the terms is the operation you're gonna do. Like an A, 4x plus 6x, that's being separated by a plus sign. So 4x and 6x, first we ask ourselves, are those like terms, guys? Do they have the same variable and the same power?
Yes, they do.
They do. So we can combine these two. When we combine 4x and 6x, we're pretty much, I want you to think of variables as unknowns. So you can say x is apples, right? And this expression is saying 4 apples plus 6 apples in total gives me 10 apples. But instead of apples, we're just going to write x because that's what we said x was. We're just combining them because they're similar. Let's look at B. B says y minus 5y. Can anyone please tell me what value is invisible in front of that y in B?
A minus?
In front of the y.
1.
There's a 1 here. So this is saying 1y minus 5y. Thank you, Vicky and Monica. So 1y minus 5y. So you have 1 banana, right? We're going to say y is bananas. You have 1 banana minus 5, but you need 5. You owe me 5 bananas. Well, once you give me the 1 that you have, what do you now owe me? You still owe me 4. Now, since you owe me 4, that's going to be, so you can combine these two and get negative 4 bananas or y. We're just, now at this point, now you're probably wondering, well, how do I do this if I don't understand you, Pacheco? Well, you can, if you want to help on doing this with the calculator, on your calculator, you can do 4 plus 6 and you get 10 and just add the x next to it. Now, if you want to combine 1y minus 5y, you'll just do 1 minus 5 on your calculator. 1 minus 5 gives you what? Negative 4. And what should be next to it?
Y.
Y. Is everyone with me so far?
Yes.
Now, let's look at C. We have 3 terms, but can we combine all 3? Yes or no?
No.
Which are the only ones we can combine?
The x's.
The x's. Well, not just really x's, x squared. You see the exponent?
Mhm.
So how can we combine those two x squareds, guys? Are we gonna add the two numbers or subtract? What are your thoughts?
Multiply.
You
We're
sure?
gonna add
We're
Okay.
gonna add. We're gonna add what two numbers?
3 and 5.
Which is what?
8
8.
8. And now what should be after the 8, guys?
squared.
Not just squared.
X squared.
X.
X squared. Everyone see that?
Okay, yes.
And then we bring down the -2. Now, I know I boxed it, but I want to reiterate, guys. Can we combine 8x squared and -2 to get 6x squared? Yes or no?
No,
Why not? What's your reasoning?
because they're not like terms, they're unlike terms.
That is correct. And I love your choice of vocabulary. Yes, that is correct. Now, anyone have any questions before you dive into the first set of practice problems? All right. Practice 1 is in the bottom corner. I'm going to go ahead and give you 2 minutes to work on these expressions. 2 minutes starting now. Good luck. Feel free to type your solutions on the chat if you'd like, or you can wait till the timer runs out and I'll ask for a volunteer to share what their answer was. The class will either disagree or agree based off of their own work, guys. Remember, I am only adding these practice problems because I want you to try these on your own. I'm hoping you can build the skills. So if you're not able to do it because you're working or you're doing something, make sure once I upload the YouTube video, you take the time to write your notes and do these practice problems. Now make sure you put the complete answer, Jennifer. -6 is missing something. So make sure, okay? There you go. And then y'all can either say y'all agree with Jennifer or disagree in the chat as she's working through them.
This one's a true.
Excellent, excellent. Anyone need more time to work on the third one, or am I good to start talking? All right. On A, Jennifer put -6m, and Vicky and Ariel agreed with her. Does anyone agree or disagree with -6m?
Agree.
Good, good, good. Now for B, she got 7a. Does anyone agree or disagree?
Agree.
Excellent. And on C, we got 2y squared. Is it -7, Jennifer, or +7?
I meant to put plus.
Okay, so we have 2y squared +7. Anyone agree or disagree with Jennifer's response? All right, to Ariel's, because Ariel put it 2. Vicky agrees. Good job, good job. Anyone get something different and they didn't know what they did wrong? Anyone need help correcting themselves?
I did.
explain-
I just got lost.
on which one, Mark?
C.
On C or B?
C.
C.
So
okay.
did I got C wrong.
Okay, let's talk about C. So C says -y squared plus 3y squared plus 7. First, how many terms do y'all see, class?
1, 2.
3.
2.
Oh, 3.
There's 3. There's this one, this one, and this one. Remember, what separates the terms, guys? What operations?
Multiplication, division, and subtraction.
Subtraction and addition. Those two operations is what separates the terms. How many terms are variable terms? How many are constant terms?
One variable. I mean, two variables and then one constant.
Cool. That's correct. Now, out of these three guys, which ones can we combine? Which ones are like terms?
The y squared and
Yeah, excellent. Now, what number is invisible in front of this negative y squared?
one.
There's a one. Does everyone agree there's a negative one?
Yes.
So we're gonna combine these two because they're the same term. They both have a y squared. So negative one. Do you owe me one or do you have one? This negative one. You owe me one. This plus 3. Do you have 3 or are you spending 3 more?
I have to.
You have 3. You have 3. You owe me 1 and you gotta pay up. When you pay me, what do you have to yourself now?
Positive 2?
You have a positive 2. But what should be next to the 2 after? What letter and power?
Y.
Y squared. Does everyone see how these two give me 2y squared?
Okay.
And then we bring down the plus what?
Plus
7.
7. And can we combine these two? Yes or no?
No,
Because they are not?
like terms.
That is correct. Does
So
that
I
make
just did addition. Yes, it makes sense.
Ah.
Thank you.
excellent, excellent. So you accidentally added, is that correct?
Uh-huh.
Be careful with the signs, Rosemary, okay? We have a negative and a positive. Remember,
Okay.
think about owing and having, and or if you want, you could, on your calculator, if you have one next to you, type in the numbers that you see. I will type in -1 plus 3.
Okay.
And whatever that gets you should be this number here.
Okay.
And then just add. It is very important if you use a calculator, like let's say numbers are your weakness and you have to use a calculator. I don't mind that you do, but use it as a resource, not to rely on it heavily. So then after you type in the orange in the calculator, you just write the answer down and then just rewrite the yellow part afterwards. That way, that's just how I would do it if I was you, if you need help with calculator. All right, let's keep moving. Now, I'm going to give you guys about 5 minutes to set up these new properties, guys, and this helpful hint. I'm going to give you 5 minutes. Good luck. Does anyone need more time to set up the properties in the helpful hint?
Yes.
All right, let me go ahead and add 2 more minutes on there, and then I'll start talking about it. All right, I know you guys are still writing, but I'm gonna go ahead and start reading over the properties to kind of highlight to you what they are. Just because I don't want you to be intimidated by the words that you'll be seeing in the textbook and your lessons, and I need you to build your comprehension. So these are properties of addition and multiplication. So let's look at the first one. If A, B, and C are numbers, then A plus B is equal to B plus A. That is called the commutative property of addition. It's very important that you guys know that what it's called and why it's there. It's what allows us to say that 1 plus 2, which is 3, is the same thing as 2 plus 1. It's 3, which is saying that the order of adding doesn't really matter because it gives us the same sum. Now look at the second trait. We have A times B is the same thing as B times A. That's also called commutative property, but it's of multiplication. So we know that the order of addition and multiplication doesn't really matter because it stays the same. Does everyone understand that? And A and B are any numbers you can think of. A can be 100, B can be 50, and 100 plus 50 is the same thing as 50 plus 100. That's what commutative property means, okay? And that's what you see right here. 2 plus 3 is the same thing as 3 plus 2. 5 is equal to 5. And the multiplication as well. These two are very similar. These are examples of the property to show you that we're not feeding you like false information. Now let's talk about the second one. So we talk about commutative. Now we're talking about associative. A plus B plus C is the same thing as A plus B plus C. So pretty much what it's saying is rather than if there's more than 2 numbers all being added, it doesn't matter which order we add them in, we'll still get the same sum. And that is the associative property of addition. Now, the same property applies to multiplication. So now that's called pretty much saying that the grouping of the numbers in addition can be changed without changing the final answer. So look at this example here. 1 plus 8. 1 plus 8 is 9. 9 plus 10 is 19. Right? That's what we got on the left side here in the example. On the right side, we add 8 plus 10, which is 18. And then we add 1, which also gives us 19. So do you see how the order of the grouping doesn't really matter when there's more than 2 numbers? We'll still get the same thing. These properties is going to really help us when we do other examples moving forward. Now when you look at these properties, do you understand on what it's trying to tell us? These facts are going to come very important as we move on in the other examples. All right. Does anyone need additional time on this slide before I move on, guys?
Just 1 second.
Yeah, let me know when you're good to go. No rush.
Okay, I'm good to go.
All right. So example 2, I'm gonna go ahead and give you guys about a minute to set this up in your notebook and then I'll get started on it, okay? All right, example 2. Simplify 2y minus 6 plus 4y plus 8. At this point in time, we should be able to tell me how many terms are there, how many are variable, how many are constant, are then do we have any like terms? So first question, how many terms do y'all see?
4.
4,
4, that is correct. How many are variable?
2,
2. How many are constant?
2,
Excellent. Can we combine anything? Are there any like terms y'all see there?
2y and 4y.
So I'm gonna show you a technique that I teach to my I teach whenever I teach this topic. I like to put a circle around all my y's, including the sign as well. And I'm gonna put a square around my constant terms. So that way, whenever we're combining them, we look at the same shape. So for the y terms, let's combine the y's. 2y plus 4y. What is 2y plus 4y? How many y's do we have in total after we combine them?
Y.
I'm
6
sorry. I heard 6y. Does anyone agree or disagree with 6y? Because what operation are we really doing with the 2 and the 4? They're being
adding.
Adding, yeah.
added.
Adding.
And 2 plus 4 is 6. So everyone with me that it's 6y?
Yes.
Now, what
Yes.
other? Now we can combine the constant terms. Minus 6 plus 8. Well, combine them. What's negative 6 plus 8? You owe me $6 and you have 8 in your account. How much do you have
14.
once you pay me the 6? So I heard 14
-2,
and I heard negative 2. 8.
Oh, wait.
So
So-
you have.
I think it's positive. Is it positive 2?
2.
I heard positive 2. So
I
let's
think it'd be 6y plus 2.
Positive 2.
So let's talk about how we got the positive 2. So it is positive 2. So let's look at the logic. 6. Do you have 6 in your account or do you owe 6 to the bank?
You owe 6.
the 06.
8. Do you have $8 or do you owe 8 more?
You have $8.
You have $8.
You have a
So if you have 8 and you pay off the bank the 6 that you owe, are you gonna have $2 or are you gonna owe $2?
You're gonna have.
Okay.
You're
You're
gonna
gonna have
have $2. Do you see that,
Okay.
Rosemary? Do you see that?
Yes.
Do y'all see that how it's a plus 2?
Yes.
Sean, are you good with the plus 2 now? 'Cause I saw that you put minus 2. Okay, excellent. All right, since you're good, here's this practice problem. I'm gonna give you 1 minute on practice 2. Good luck. All right, that was a 1 minute timer. Anyone still working on the practice problem? Anyone need more time? All right, Ariel put 7z plus 1. And I see that Mark and Jennifer agree. Anyone disagree with 7z plus 1?
I agree. I got it right too.
Good job, Melanie. Good, good, good. Yeah, that is correct, everyone. That is 7z plus 1. Does everyone have the comfort of getting there? Does anyone need me to break down any steps for this practice before I move on?
I think I'm good.
All right, good job. All right. All right. So, all right, no one said they needed help, right? We're good. All right, let's go.
Sorry, I couldn't get myself off mute.
Yes, Monica?
If you can explain to me, +5, I guess.
Okay, like the constant
Min-
term? The minus,
Yeah,
okay.
5 minus -4,
Of
or how are we reading this?
So remember the properties we said that the order that it can be moved around with the last
Right.
property. Yeah, so you can take advantage of that. So if you wanted to, you can rearrange this and do 6z plus z plus 5 minus 4. Rearrange the z's together and the numbers together.
Okay,
And at that point, you don't have to write print. I don't recommend this part, but you can see that we're doing 6z and z, right? And
Right.
total gives us what?
7, 7z.
That's correct. Now the constant terms, what are we doing here? What does it say here? 5 minus 4.
5 minus 4,
Which is what?
or -4, 1.
Yeah. So if it helps you rearrange, you may definitely do so, Monica.
Okay.
I actually used your circle square method.
And did it help?
Yes.
Yes, it does.
It did.
All right. Well, let's see how it does for the next few examples. You guys ready? All right. We have 3 new examples. We have 3, 4, and 5. I'm gonna go ahead and give you guys about 2 minutes to set it up, and then I'll begin working them out. Now, if you want to try to do this on your own, following my methods, I recommend so. But if not, you can wait for me to work them out. Starting now. Good luck.
I have a question. For number 4, it says 4x plus 2 minus 5x plus 3. Would you do the 4x minus 5x? Because it's in front of the 5?
That is correct, Jennifer. The 5x is minus or negative, so that is taken away. That x term is negative. That is correct.
Okay.
Let's see, that was enough time to get started. Let's look at example 3. 6y plus 12y minus 6. Out of these 3 terms, which ones can we combine?
6
6y.
and 12.
And 12y. And then we have only one constant term. So when we add those two, we get 18y, bring down the minus 6, and we are done. Let's look at B. We have 4 terms. We can combine 4x with minus 5x, and we have plus 2 plus 3. Let's combine the x terms first. 4x minus 5x. So 4x, do you have 4 x's or do you owe me 4?
Oh, you?
You
Oh, we have
you have because it's what kind of number?
Positive.
Positive, but you owe me how much?
5.
Since you owe me 5 and you have 4 on you, once you give me your 4, you don't have anything, but you still owe me how much?
1.
1.
1. And now we combine the constants. What's plus 2 plus 3?
5.
And we're done.
Wait, so you just have a negative x, you don't have a 1x?
Oh, you could do negative 1x. You could do negative 1x. Because remember class, what
Right?
did I say, guys? What did I say? I said negative 1x is the same thing as also negative x. Y'all remember that?
Yes.
Okay. So it's
These
the
are
same thing.
this as the same thing, y'all. If you want to keep writing the 1 because it reminds you it's there, I recommend it. If you already know, oh, it's there already, I'm good, then you don't have to write it. It's up to you though. I'm not gonna force you. I'm not that professor that's like my way or the highway. Nah, it's like, do you get it? Are you good?
What about like in the homework? Is there a certain one that we have to put in for like the answers?
Ah, so that's great that you're asking that. And now in my math lab, if you were to type in the left one, you should still get it correct.
Okay.
Yeah, you should. Now, if you ever have any math lab issues, like you type in the correct answer and it's not coming out, you better take a picture with your phone or screenshot it on your device and you send me an email immediately so I can take care of it. Okay. So I can either tell you, hey, you actually got it wrong. Sorry, it's this. Or I'll tell you, oh, you got it right. That's a mistake. Let me fix it. And you know what I mean?
I was messing up on the one that the one that I need help with. It was the negatives that I kept messing up. I got the answers correct. It was just, I didn't have the negative, or I put the negative and it was positive. And I was like,
Ah.
wait, huh? I'm confused. That's why I need help.
Okay. All right, look at number 5. I know, don't judge me. I put a lot of letters. I just wanted to really challenge you guys. So how many shapes, if you're doing my shape method, how many shapes are we going to have to use to denote the different terms?
3.
3, right? We're going to have the circles for my x terms, my squares for my constant terms. I'm going to go ahead and use a heart for my y's. All right. Now, if there's more than one letter in an expression, guys, and you're probably wondering, well, what's the proper notation? What should go first? I want alphabetical order. So the X term will go first, then the Y, and the constant term is always last. All right, guys. So let's look at what we get for the last one. So 2x plus 4x. Ariel, you're off by 1 letter, Ariel, in your answer. So you want to change that.
It's 7y.
There you go. But let's look through the x's. So 2x plus 4x is 6x. Combine the y. So we did the x's already. Now the y's. 3y minus 10y. You have 3. You owe me 10, so you're still going to owe me 7 after you give me the 3. Minus 5 plus 11. You owe me $5, but you got tipped 11 from the restaurant you work at. After you give me the 5 that you owe me, you're going to have 6 to yourself. And this is the final answer. Now, what questions does anyone have on simplifying and combining like terms? Is it starting to click how we're using everything that we've been learning so far?
Hold on, I missed something.
What's up?
I got 6x 16 and negative 7y.
Because so the 7y is correct. It's the 16 you got wrong. What kind of 5 is it, Monica?
Oh, crap. It's a negative 5.
Okay, so would you have $5 or do you owe me 5?
I owe.
But you have 11. So when you then you'll have to subtract, right? You with me on there?
Correct.
Okay, good. Thank you for asking. Anyone else have any other questions or comments or concerns from these examples before we move on? Because you're gonna have to practice them right now. Y'all ready for your own practice set?
It's little mistakes like that that I get wrong on exams when
So
Me
the
too, Monica.
so so let me give you
God.
some words of advice before I give you the practice problems. You want your mistakes to happen during class, during lecture, and during practice problems. So that way you can catch yourself and then make a little note. Write your symbols. Make sure you look double check everything. You know, like you utilize your resources. Okay. Ready for your practice set, guys? Y'all want 4 or 6 minutes?
6.
All right. Good luck, everyone. Now, I know this is a practice set, guys, but I want you to start focusing on the college order. I want you to go letters first, constant term last, and then if there's more than one letter, do alphabetical order. Okay, guys? Now, if you have the correct answer, just rewrite it in the next line with the correct format. That way you can get used to that college setup.
Sir, I got a question.
Yes, what's your question?
So for number 5, for
Yes.
the x's, it'll be -9 or it'll be +9.
What operation is in front of the 9x? It's a minus. So since the minus is in front of the 9x, it's gonna be negative 9x. And then you have to combine it with, is there any other x terms on there that you see?
Yes, sir.
Make sure you combine them correctly, okay?
So it'll be, all right.
All right, guys, that was the timer, the 6-minute timer. So for number 3, I'm looking at the chat. Someone said they got 18y minus 6. Is anyone disagree with this? Because I see a few people agree. Anyone disagree with 18y minus 6? All right, Sean, what did you get, sir? Or how would you first you gotta look at the problem, Sean. It says 6y plus 12y minus 6, right? Now, out of these 3 terms, which ones can you combine? No need to apologize, sir. We're here to help. So which out of 6y, 12y, and -6 can we combine anything? Are there any like terms?
6 plus 12.
Yep, 6 plus 12, right? Because they both have a y term. So when we combine 6 and 12, when we add them, 6 plus 12 is 18. And we write 18y because it's 6y and 12y. And that gives us 18y. And -6 can't combine with anything else. So we just write it after the y and we're done. And we're just adding the numbers here. 6 plus 12, which is 18. Now for the second one, I got someone put 8y plus 3. Does anyone disagree with this one?
I got 6y plus 3.
You got 6y? So let's look at the y. So 7y, is that positive or negative?
Positive.
Look at the other y. Is that positive or negative?
Positive.
So would you add them or subtract them if they're both positive?
Positive. Add them. Sorry.
And then you should get the 8y. You see that, sir?
Mm-hmm.
Okay,
Yeah.
good. Okay, good. Did you get the +3 though?
Yeah.
Okay, good. On 5, this one was a little intense, right? Because there's a lot of terms going on there. But which one would you focus on first? So I saw somebody in the chat say -9x with -x. When we combine those two, what do we get? You get negative 10. You get negative 10x. That's correct.
I'm
Now,
sorry, where'd the negative come from?
like for the final answer or in the problem?
For the final answer.
Because you gotta look at the logic behind it. So the two
Oh,
term,
Yes, I see it. I see
yeah,
it.
negative 9x minus x. You owe me 9 and borrow another dollar. Now you owe me 10. Now look at the y values. So we have negative 7y minus 2y. So you owe me 7 and you borrow 2 more. Now you owe me a total of how much?
9.
Minus 9y. And then for the last constant term, we can combine what two terms? The 2 and the,
12.
which gives us what?
14.
And we're done. Does everyone understand the breakdown of how our logic behind these things?
So
Oh, go ahead.
no, go ahead.
For the negative 7y and the y 2y, yeah, the 2y, you add those?
Well, yes, because you want to think about like the numbers. So remember how I'm using money. So 7, negative 7. Do you have 7 or do you owe 7?
Oh,
Oh, minus 2y. Are you spending 2 more or did you obtain 2 more?
I don't
Yeah.
know. 'Cause there's a subtraction symbol.
So when and money, when do you subtract? When you spend or when you get?
When you spend.
So
You
you
have to
owe me
add 'em.
7 and you spend 2 more. So you're
Oh.
gonna have to add the money that you spent, but since you're owing it, what kind of answer should it be?
Negative.
There you
Or-
go.
Yeah, yeah.
So technically you're adding them, right? 7 plus 2 is 9, but it's gonna be a negative 9 because you're spending and you owe, which is just a negative situation. Does that make sense?
Yes.
yes, it makes sense, but it's still a little tricky. You know, you just got to pay attention to those signs.
Exactly. Pay attention to the signs and tell yourself the story. I remember when I taught the money thing to my high schoolers, I would hear them in the groups. All right, negative 14 plus 20. Okay, I owe Pacheco 14 and then I got 20 bucks. And then it'd be $6, and then I'll be like, there you go. But it's just numbers, you got to give yourselves a scenario so you can comprehend. Remember, adding positive numbers is because you have it or you got it. So yeah, let me go ahead and set up the next examples real quick, 6 and 7. I'll give you guys 1 minute to set this up and I'll go ahead and work it out. All right. So example 6 and 7, guys, and you're just multiplying it. Excellent, LJ. So we have 5 times 3y. Let me talk to you what's going on with example 6. All right. So 5 times 3y, that's pretty much, remember the commutative property, we can move the parentheses around the 5 and the 3. 5 times 3 instead of the y and the 3, because 3y being multiplied, right? We'll multiply 5 and 3. It's just 15. And then followed by the y. And we're done. And then we look at the example 7, negative 2 times 4x. We can do the same thing, right? So then we'll do negative 2 times the 4 and then leave the x outside, which is negative 8x. Very simple, right? I'm not gonna have you practice this because it's common sense, it's just multiplying, guys. But everyone understand how that works, right? How the letter is still there. Because technically we're multiplying three things here. We're multiplying the 5, the 3, and the y. The -2, the 4, and the x. But we don't know what x and y is, so that just stays with whatever these numbers multiply to. Okay, guys? That's very important here. Technically, we're distributing the 5 to this, but there's only one thing in the parentheses, so that's why we only have one arrow in this example. Any questions before I move on to the next examples? All right. I'll go ahead and give you guys a 1 minute to set up finish writing this down because I know I wrote some extra stuff on there. Now move on to the next slide. All right, a 1 minute timer has passed. Does anyone need additional time before I move on, guys? All right, let's go. Example 8. I'm going to give you guys 1 minute to set up example 8, and then I'll get started. Now we're going to apply the distributive property finally. I'm going to give you a minute to set up the example. All right, example 8, y'all. We're going to use a distributive property to simplify or multiply 5 parentheses x plus 4. So what is that saying, right? So this example is telling us that we have 5 times x plus 4. We're going to multiply or distribute this 5 to all the terms in the parentheses. And the way you show me that you're going to distribute the 5 is by writing arrows from the 5 to everything inside the parentheses, all the terms. And remember, we know terms are separated by plus and minuses. So there's going to be 2 arrows in this scenario. And now we're going to go ahead and multiply it. So this arrow, so this first arrow, the smaller one, it's saying 5 times x. So that is 5 times x. And then we do the plus again, right? Because the plus is inside, times 5 times 4. Notice how the 5 is multiplying to the x and multiplying to the 4, separated by the same operation that's in the middle, which is the plus sign. And now we simplify. We know 5 times x is just 5x. Plus 5 times 4 is just a positive 20. And we're done. Does everyone see how distribution is working? You're multiplying the number on the outside to the terms in the inside. Let's look at example 9. I'll give you a quick few seconds to write it out. Multiply -3 parentheses 5a plus 2. So what that is we're gonna draw, how many terms, guys, do y'all see inside the parentheses of example 9?
2.
So we're gonna draw 2 arrows to show us that we're gonna multiply that -3 to the 5a and to the 2. So let's go ahead and write equals.
Would it be negative 15a or plus -6?
Good. One second, let me just, I'm showing you how the step looks like. You are correct. It is -15a plus -3 times 2 is -6. That is correct. But remember, we don't really want to have plus and minus together. What happens when we combine plus and minus? What operation is it?
Addition?
It's positive, isn't it?
A positive and negative is positive? You sure? Look at the little box.
Negative.
Never-
Negative.
Negative.
It's a -6. So these two are the same thing. When you have a positive and a negative, it's a minus overall. If it was a positive, it would be a plus. If it was a negative, it would be a plus. When the signs are different is when it's going to be negative. Is that understood, class? Does everyone understand how we started and how we ended? Everyone with me on that path?
Yes.
Hey, awesome, LJ, awesome. Ariel, I see that you guys are working through on your own. Nerd status. All right. On the last one, you're gonna distribute the 8, right? So draw your arrows. Now you notice how I'm doing the step where I put like the dot to show you what's hoping down. So we know the 8 is gonna multiply the x, and we know the 8 is gonna multiply the -4. But I'm gonna leave it like that. Now, if you want to put the number second, like you want to do x times 8 instead, and then -4 times 8, like put the 8 after the terms, you can. Because remember, does the order of multiplication matter, guys? 2 times 3 is the same thing as 3 times 2. Remember the property we learned that we wrote earlier? So then we get x times 8 or 8 times x is just 8x. -8 times 4 or -4 times 8 is just -32. And we're done. And that is the distribution property, guys. Any questions on what we did on this example, guys? Any questions? All right, let's see how everyone does on the practice problems. All right, I'm going to give you guys 5 minutes on this one. Good luck.
Sir,
Yes, what's up?
which ones did you say were gonna be somewhat like the test?
The review questions. When I send out the review after class.
Okay. Thank you.
My pleasure. All right. Does anyone have any questions, comments, or concern on these practice one? Would anyone like me to work out any of them? From the look of the chat, guys, let me see. 21a minus 15 is correct. 30 minus 6y correct. And 8y. Yep. So ones on the chat have been correct. Does anyone want me to explain any of them thoroughly before we move on? All right, let's go ahead and move forward, guys. Good job. All right, now we're gonna be doing the same thing we've been doing, but now we're adding complexity to it. Now there's other stuff to do, maybe do it twice, maybe whatever. I'm going to give you guys a minute to set up the first example before I move on and work it out for you guys, okay? Now, if you want to try to work it out yourself, you may do so, but remember, these are notes, so I will be working them out regardless. One minute timer ended. So let's see how we do on the first one. So example 11. So we want to do, what property is it called with the 2 in front of the parentheses? What property am I going to have to do? So it's the letter D. I'm going to have to.
Multiply.
Yes, ma'am. I'm going to multiply by distributing. I'm going to distribute the 2 to the 3 and to the 7x. Now question, y'all. Am I going to distribute the 2 to the negative 15? Yes or no?
No.
Why not?
Because it is its own property.
It's not that it's property. It's a better way you can say it. LJ kind of said it. He said it's outside of what?
Parentheses.
The parentheses. Everyone understand that the 2 only multiplies to the inside of the parentheses, not the outside. So 2 times 3 is what?
6.
So then we get 6. 2 times 7x is
14.
14 what?
X.
Good. Bring down the minus 15. Do I have any like terms, y'all?
No.
You sure?
Yes, you do. Sorry.
Which ones?
And 6 and negative 15.
So if you have $6 because it's positive, but you owe me 15, after you give me the 6 that you have, How much do you have?
9, -9.
-9. So then we get 14x minus 9. And we're done. Does everyone see how we distributed, brought down the 15, and then combined? Same concept we'll do to the other two examples, okay?
So you wouldn't, the way we did the 2, we wouldn't do the 15 to the 3 and 7?
That's correct.
Okay.
So the next one, would it be -2 plus 10? No, it's -2 minus.
So let me go ahead and change my color. So how many times are we gonna have to distribute in the second example? How many times? Twice, right? I'm gonna have -2 times this x here and times the -5. And then I'm gonna multiply the 4 to the 2x and the 4 to the 2. So let's see what happens, right? So -2 times x is what?
2, -2.
Just -2?
-2x.
There you go. And then we're gonna do -2 times -5. Two negatives make a what?
Positive
And 2 times 5 is
10.
10.
10. Everyone comfortable with how I distributed -2?
Yes.
Okay. Now we're gonna distribute the 4. What kind of 4 am I distributing, y'all?
Positive.
What's a positive 4 times a 2x?
Negative. Fool me.
A
Eight.
a
No,
negative 8 or
positive
positive 8? Positive 8. You see that, right? A positive 8, what though? What should be after the 8?
X.
X. Y'all with me on that? So now, last but not least, we do 4 times a positive 2, which is just another 8. Now we do like terms. What can I combine -2x with?
8.
8x.
Good. Now what can I combine 10 with?
8.
The 8.
Everyone with me so far?
Yeah.
So -2x plus 8x, what does that simplify to?
6.
Good. And then 10 plus 8,
18.
and we are done. Is everyone with me so far?
Yes.
All right. Last example, y'all. I'm gonna give y'all a minute to set that up. While you're setting up the last example, y'all, what number is invisible in front of this parentheses that we don't really see?
1.
1.
1. What kind of 1? What type?
Negative.
Negative.
A -1. Everyone remember that, right? -1y. I mean, not y, but -1. Okay, good, good, good. Ari already finished the last one. If anyone wants to share with her before I work on it. All right. So let's get started on it. All right, so we're gonna distribute the -1, right, to the x and the 4. Now, when we multiply a -1, ladies and gentlemen, we're gonna change the signs. That's all a -1 does. -1 times x makes the x opposite side. So x was positive, so it's just gonna make it into -x or -1x, right? Because it's now from a positive to a negative. Now a +4 times a -1 is just going to make a -4. So you see how the signs just became positive to a negative? That's the power of a -1. Now, notice how I didn't draw any arrows to the 5x and the 16. Can anyone explain why again?
It's not in parentheses.
It's not in the parentheses. Now we bring it down and we combine our like terms. We can combine -x with positive 5x, and we can combine -4 with 16. What's -x plus 5x? You owe me an x, but you have 5 on you. So how much do you have left after you give me the 1?
-4.
Four.
Is it 4x or -4x?
Negative 4x.
Look at the x's. This x is only negative, right?
So it's positive.
As
Positive 4x.
as positive 4x. Because you only owe me how much, guys? How much do you owe me?
1,
But you have how much on you?
5.
So are you gonna have 4 left or you're gonna owe me 4? Think about it.
Have 4 left.
You're gonna have 4 left. You see that? Okay. Now let's look at the numbers. Negative 4 plus 16. Negative 4 plus 16. You owe me 4, but you have 16. After you pay me the 4, you have how much left to you?
12.
And we're done. Let me ask you guys this. Are y'all liking the multiple examples of different types of ways the problems can be written? Is this exposure good for you? Is it helping you?
It's
Okay.
Yes.
confusing, but yes.
Good. Okay, good.
Just to elaborate on this, I seriously am enjoying it. Like I said the last time, it took me months of tutoring. I caught it, but I didn't. And it has a lot to do with the foundation. This is a lot of foundation that I did not know
And okay.
whatsoever. I didn't know any of these rules. And now it's making sense. Now it's starting to click.
Oh, and that's amazing, Monica. Thank you for sharing that because you're right. This course is a foundational math course. It's algebra foundation. So I'm honored to have been able to be your professor this semester in this class and build that foundation with you because math is my passion and it should not be your obstacle of pursuing what you want to do, you know?
Well, and also the way you're explaining it, because I took another class and the way they explained it there, I didn't catch it. I had to drop it. So you're explaining it very well. I appreciate that.
Oh yeah, I've been in education for a long time and it's been my biggest passion. You know, math changed my life growing up, you know, so I would like to impact you guys the same way I was impacted. So I appreciate your comments and I'm hoping I can help you grow as a mathematician, as a student, and as a person. And I can't wait for you guys. I know, right? It's nerdy. You're gonna take a test. It should be boring, but I'm excited for you to challenge yourself and and see you get a good grade on the test. Like I want to see you push yourself and succeed because it's possible, guys. Like, and I'm here to help pave the way for you guys. So let's see. Enough talking. Show me how you do with these practice problems. Show me your understanding and show me that it's making sense. Good luck. I'm gonna go ahead and give you 5 minutes on this one. Let's see how you do. Good luck. Okay, that was the time. Anyone still working on these examples? Anyone need more time? All right. So for practice 11, the first one, we got number 1, 10y minus 23. Anyone who got that, that is correct. 10y minus 23. Now for number 2, two different answers. We have 3x plus 22 and we have 2x plus 22. What does everyone else think?
3x 22.
3x and 22. That's correct. Vicky, did you catch your mistake, ma'am, on what happened? Okay, good. Okay, cool. As long as you caught your mistake. And then the last one, I think someone said it. They put, let me see, 2y minus 13. Anyone not get that? Anyone like think it's right, wrong? Like I think it's right. Well, it is right, but anyone not get it?
I multiplied wrong. I put 6y minus 12.
You did what today? One more time.
6y and then negative 12.
Ah, now look at the math. Do you see where? How did you?
I don't think I did my steps right.
So okay, so the last one, right?
The last one.
So talk to me through your process, Rosemary. When you wrote it down, what did you do first? Okay.
So I did my, go ahead, I'm sorry.
Oh, sorry. Let me write the first answer. The first answer was 10y minus 23, right? That was the first one. So the last one. So Rosemary, so what do you do first? What number are we gonna distribute, Rosemary?
The 1.
What kind of one?
A negative 1.
So when we multiply to the y becomes what kind of y? What's negative 1 times y?
It's negative y or negative 1y?
Yeah.
Negative y. Okay.
Yep. And then what's negative 1 times 1?
It's 1.
What kind of one?
A positive 1.
Are you sure? It's a negative 1 times a positive 1.
Okay, so it's a negative 1.
It's a negative 1. And then what do I do with the 3y and the minus 12?
Multiply. So bring down my plus sign and then.
Is there anything going to be done to this? Are we going to multiply this to anything, or am I just going to bring it all down?
I brought it down.
That's correct.
And then I brought down my negative 12.
Good. After we do that, now we combine our like terms. What can we combine, Rosemary?
The y's.
The y. So combine the y's first. So talk to me the process. Do you have a y? Do you owe a y? How would you do
We
it?
owe a y.
And how much do you have?
2. So 2y.
So you have 2y, right? Okay, good. And now combine the what next?
The minus 12.
With the what?
Oh, with the minus 1.
And how do we combine those two?
I did my steps wrong. That's what I did.
Okay, so you caught yourself? You good now?
Yes.
Okay, good. As long as you see what you did wrong, so you can avoid it, okay?
Okay. I got it. I wrote it down.
Excellent. Anyone else? Any other questions?
How did you do number 2? Like, how did you get the 3x?
The 3x, I could definitely show you. All right, let's look at number 2, guys. So let's go ahead and distribute, Jennifer, the negative 7, right? What's negative 7 times x?
7x.
What kind of 7?
Negative 7x.
What's negative 7 times minus 1?
7.
What kind of 7?
Positive.
And now I'm going to distribute the 5, right? What's 5 times 2x?
10x.
What's 5 times 3?
15.
Now combine our like terms. What can we combine?
The 7x and the 10x.
So tell me the logic. Do you have 7x or do you owe me?
You owe 7x.
But how much do you have?
You have 10
Why do you have 10?
because it's the plus.
Plus, so since you have 10 but you owe me 7, what happens after you pay me the 7 you owe me?
You're
How much do you have left?
So you do like -7 minus 10, right?
Not -7 minus 10. So if you don't know how to plug it into the calculator, plug in the numbers that you see. So what do we see here?
-7
So in
plus
your so you do -7 plus what?
10x.
10. You plug this into your calculator.
Get it
That
now.
would tell you the number that you're supposed to get in front of the x.
Uh,
Because it's -7 plus 10, right? What do you get?
I got -3x.
-3x. Did you plug it in exactly the way I have it written here? -7 plus 10.
I mean positive, I'm sorry.
Okay, cool. And then it should be an x, right? And then what do we do with the 7 and 15?
The 7 and 15 you add
And you get what?
22.
And we're done. Does it better understand how you get the x? How do you get the 3, Jennifer?
Yes, I wrote it wrong.
Okay, good. All right. And just like that, guys, we finished the first lesson. I'm gonna go ahead and give you guys about a 5-minute break and we continue at 2:41, okay? We'll use the restroom and get some water. All right. 3.2, solving equations. So the review of addition and multiplication properties, which is what you already have in your notebook. I'm not gonna have you write that again, but we're gonna start with example 1. And wants us to solve the equation y minus 5 equals -2 minus 6. Let's go ahead and draw a line down the equal sign. Now remember that we know that an equation is literally just an expression equal to another expression, correct? We wrote this last week. Well, what does that mean, right? What does that tells us? What can we do with that information? Well, since we know an equation is an expression equals an expression, we know that expressions can be simplified, correct? Now look at the expression to the left, the y minus 5. Can I combine anything together, any like terms on the left side of the equation? Y minus 5. No, right? There's nothing to combine, so we just bring it down. But look at the right side, however. We have the right side says -2 minus 6. What's -2 take away 6? Well, how can we combine those like terms? They're both constant terms. So -2 minus 6. You owe me $2 and you spent 6 at the store. So now you owe me in total how much?
-8.
-8. That's correct. Now we have to solve for y, ladies and gentlemen. What's the one step we have to do to get y by itself? How do I move a -5 to the other side?
Multiply it.
Remember, we have to do the opposite operation.
Divide.
Look at what operation do you see right now?
Add it.
We're gonna add it because the opposite of minus is plus. Everyone agree with me? Remember, adding goes to subtracting, so I would write add goes to subtract. They're backwards, and then multiply goes with divide. So this becomes 0, bring down the y, -8 plus 5, guys. You owe me $8 and pay me off 5. So now you owe me how much?
-3.
-3, that's correct. Now, remember, I showed you how to check your solution. So I want this to be a habit for you guys. If I show you a way to check yourself before you wreck yourself, I expect you to utilize it. It is a resource additional that you learn in mathematics. So we're going to plug in -3 for y. So then we're going to get -3 minus 5 equals question mark -2 minus 6. But now we have to kind of simplify the left and the right side. Well, we know the right side is -8, right? Because we did it in the problem ourselves. On the left side, -3 minus 5 is also -8, which is true. So check mark, true. So therefore, this is the solution for example 1. Now go ahead and apply the same procedure, and I want you to do practice 1 on your own. I'm going to go ahead and give you guys 2 minutes starting now. All right, guys, that was the timer. Does anyone have what did y'all get for the answer for the practice problem, guys?
4.
Positive 4 or negative 4?
Positive 4.
Okay. Did anyone agree or disagree with that answer?
I was stuck between +4 and -4.
Yeah, I'm stuck there too.
All right, let's go ahead and work it out, guys. So we have this practice problem, right? So the first thing we do is draw the line down the equal sign. Can I combine anything on the left side? No,
No.
right? So bring it down. Can I combine anything on the right side? Yeah. What's 1 minus 3?
2.
What kind of 2? -2.
Yeah.
All right. Everyone with me how 1 minus 3 is -2.
Yes.
Okay, good. And then Josh, Sean, are you guys good with me? Y'all with me on this step that x plus 6 equals -2. All we did was combine these two. Okay, good. Now, remember, we're solving the equation, guys. We want to get x alone. So we have to do the opposite operation. What is the opposite of what's happening to the x? X is being what? +6, right? And what is the opposite of +6, y'all?
Subtracted.
Subtract 6. And what we do to one side, we do to the
Other side.
So then this becomes 0, bring down the x, and now we combine the right side. The right side says -2 minus 6. So -2, do you have to or do you owe me 2?
We owe you.
You owe me -6. Are you spending 6 more or did someone pay you 6? Did you get $6?
Spending 6 more.
You spend 6 more. If you owe me 2 and you spend another 6 in total, how much do you owe?
-8.
Negative.
Now, do we know if this is correct? No, right? We want to check our work. So we're going to do check. It'll be -8 plus 6 equals question mark 1 minus 3. Well, we know 1 minus 3 is -2. Let's simplify the left side. You owe me $8, but all you have was 6. You're still going to owe me 2. So this is true. So this is correct. What parts threw you guys off on this example and this practice problem? Talk to me.
The second part where you do I did x plus 6 equals 1 minus 3. And then I did x plus 6 and then -2. And then I forgot the last step.
Okay. And did you have an equal sign between the x plus 6 and -2?
Yes, I do.
Okay, good. And you got stopped there. You didn't know to move the 6, right? That's where you didn't know what to do.
Yeah.
Okay, but you're good now?
Yeah.
Okay.
I had got a +2 instead of -2.
But do you see why it's a -2 though, right?
Yeah.
And then Josh and Sean. So Sean, you're saying to the Josh thing, the 1 minus 3, that part had you? So for the 1 minus 3 part, guys, we can combine those two gentlemen because they're both constants, right? It's just the numbers. We can combine numbers. So it's a 1 minus 3. So if that part subtracting part gets to you, I will put on your calculator. If you don't have one yet, use your phone, do 1 minus 3, and it will result in the -2. I want you to remember that I don't require any of you guys to become calculators. You don't need to do this math in your head. You can use the technology to help you do computation. That is okay. My thing is, I need you to know that 1 minus 3 is 1 minus 3. So that's how you plug it in. Does that make sense? I need you to understand what's happening here. I need you to understand that they're being subtracted and that they're like terms. As long as you know that, you can plug it into your calculator to get that -2. Is that understood, y'all?
Yeah.
Okay. And then from there, you have to manipulate the equation, guys. So to move things to the other side, +6 is the opposite is -6. But we have some examples for you to see. So right here, we have 3 more examples. So I'm gonna give you guys a minute to set up example 2 first, and then I'll start working it out. Okay, guys? All right, let's take a minute to look at example 2, guys. So example 2, 3y minus 7y equals 12. So this is still an equation like we did in the last lesson, but now there's more steps for us to do to get to the solution that we need. So the first thing we need to do is we need to simplify both expressions on each side so that way we can get the variable by itself. So look at the left side. We have 3y minus 7y. Are any of those like terms that we can combine?
Yes.
Yeah. What's 3y take away 7y?
4y.
What kind of 4?
-4.
Yeah, -4y equals 12. And now that 12 is simplified, we don't have to do anything on the right side. We can just bring it down. Now we just solve for y. What operation is happening with the 4 and y that we don't see? They're being what?
Slide.
Multiplied, right? So what's the opposite of multiplication?
Division.
So we're going to divide both sides by -4. This becomes a 1. So we get 1y, which is just y. 12 divided by -4, which is -3, and we are done. Now, it's very important that you still check your work, though, because remember, you have a way to check your solution without me being around or having to use a math app. You can do it yourself. Yeah, and this is what the independence is from. So we're going to plug in -3 for y, wherever we see it at, and then equals 12, question mark. 3 times -3 is -9. -7 times -3 is +21. -9 plus 21 is 12, which is true. So this is the correct solution. Now let's take a look at the second example here. Z over -4 equals 11 minus 5. So draw the line down the equal sign. I know some of you guys are probably still setting this up, right? Now, the left side, z and -4, nothing can simplify there. Look at the right side, 11 minus 5. Can we combine those like terms?
Yes.
What's 11 minus 5?
-6.
You sure? Look at the way it's written.
Oh,
Positive.
6.
You agree? You see that it's +6, Rosemary? Okay. So then we bring down the z over -4. Now, can someone tell me what operation is happening between the z and the -4?
You're gonna multiply, or it's division, but you're
It's
gonna
division.
multiply
We're gonna multiply by what?
4, -4.
-4. And what we do to one side, we do to the
Other.
So then this becomes a 1, right? The 4, so that's a z. 6 times -4 is -24. And then we go ahead and check it out. So then two negatives become a positive, and then 24 divided by 4 is 6 equals 6, which is true. So we're good with the second example. Now, if you're struggling with the examples of the steps we're doing, make sure you're rewatching the lectures, guys. Make sure when you're on my math lab, you do help me solve this. You watch the videos, you watch extra notes. There's a lot of resources available out there that for you to utilize for yourself. Now, tutoring can also be with 3 people. It could be with the online on Canvas, on campus with PAC, or me with by appointment. And it just depends. So I would utilize everything you can if you're still struggling heavily, especially before the test, guys. The test is going to be due on Wednesday, and I'm going to open it up Wednesday. It's going to be due Sunday, but it'll be opened up Wednesday. So as long as you get the review done and you understand the review, you'll be golden. All right, look at the last example. I'm going to go ahead and draw a line down the middle. Now, on the left side, are there any like terms that I can combine on the left side?
5 and the 4,
What's 5x minus 4x?
1x.
So then we get 1x plus 2. Now, can I combine anything on the right side, y'all? Can I combine 7 and minus 19?
Yes,
Why?
because you subtracted.
Well, yeah, because we're subtracting, but we're adding over here, but we didn't do anything with the 2 and the x. Why didn't I combine x and 2? What's the difference between the 1x and 2 and the 7 and 19?
They're not the
The
same.
19 are like terms, the 1x plus the 2x are unlike terms, so you didn't add them.
But
fully.
7 and 19 are like terms. You see that, Rosemary? 7 and 19 are both constants. They're both just numbers, so we can just combine them.
Okay,
So if you have $7 and you spend 19 at the store, what are you gonna owe the bank?
Negative $12.
Correct. So now all we have to do is solve for x, y'all. So how would you solve for x? What operation? So we look at it. We have x plus 2 equals negative 12. How do we get rid of plus 2?
Subtract it.
Subtract it. What we do to one side, we do to the
Other.
This becomes 0. Bring down the x. What's negative 12 minus 2? You owe me 12, but borrow 2 more.
Negative 14.
Negative 14. So then you would check that answer out. So it would be 5. So you would check. You do 5 parentheses negative 14 plus 2 minus 4 parentheses negative 14 equals question mark 7 minus 19, which is negative 12. And then simplify the left side. So 5 times negative 14, that's negative 70 plus 2. Negative 4 times negative 14 is positive 56. Add and subtract from left to right. That's negative 68 plus 56 is negative 12 equals negative 12, which is true. And you can always use your device, your calculator that you have to help you check your work as well. Like you don't have to do all of this by your head. I do this because I know I'm able to. If you guys are still struggling, use your calculator, use whatever you have to do to help you write the steps out. Okay, guys? And there's no such thing as it's bad to do that, you know? All right, any questions before you try some out on your own? All right. I'm gonna go ahead and give you guys about 6 minutes on these questions. Good luck. I'm gonna go ahead and do roll call, guys, while I have some of you guys on here already, just so I can get the attendance updated. All right. Isabella. You can type it in the chat or unmute yourself. Isabella Alanis. Nope. Alina,
Here.
Christopher,
Here.
Jasenia, Jennifer,
Here.
Lydia, Monica, Sean,
Here.
Gabriela, Mark,
Here.
Damien, Isaac, Savannah, Melanie,
Here.
Alyssa,
Here.
Matthew,
Here.
Mario,
I'm here.
Vicky, Alex,
Here.
Catherine, Jose,
Here.
Rosemary,
Here.
Johnny, Josh,
Here.
and Ariel. Yes, Ariel, I called you. But you're good. I got you, man. All right, guys, that was the timer. Anyone have any questions on any of these practice problems?
Can you go over the last two?
The last two, okay? Before I start the last two, anyone need me to work out the first one? Anyone interested in the first one? So, okay, let's look at the first one. So we have 10 equals 2m minus 4m. So first draw the line down the equal sign. And then we look at the left side. Can we combine any like terms here on the 10? Nope, so just bring that down. On the right side, we can combine 2m minus 4m, which gives us a negative 2m. Now we gotta get m by itself. Since they're multiplying, we're gonna have to divide negative 2 on both sides. This gives us a 1. So then we get m equals 10 divided by 2. Negative 2 is negative 5. And we're done. Now you could check your answer to, this is a practice problem, so I recommend you do so. Solve the second one. Let me go ahead and switch my color up. Negative 8 plus 6 equals a over 3. Well, negative 8 plus 6 are like terms, they're both constant. So when I combine them, I get a negative 2, and I can bring down a over 3. Well, when we have a fraction like this is another way to divide. So we're going to have to multiply 3 on both sides. So multiply the 3, this becomes a 1. So now a is by itself. 3 times negative 2 is negative 6. And then once again, we have to check our answer, right? Now we're on the last one, the third one. So let's go ahead and look at the right side, guys. Can I combine anything on the right side, y'all? Yes or no?
Yes,
What can we combine? 17 and 2, which gives us what?
I put 19.
That's
put-
correct.
Okay.
It's 19. Everyone with me? We just
Yeah.
add the
Yes,
two,
sir.
right? Can we combine anything on the left side, y'all?
The negative 6y and the 7y.
Yep. When we combine those, what does that add up to?
I put,
One, positive one.
What?
Is it
Positive 1y.
okay, I was right.
Bring down the negative 1, right? So now we just gotta solve for y. And remember, to manipulate an equation, so that we just rewrite it better, right? Y minus 1 equals 19. It's just an equation like we did last lesson. We want to get y by itself, right? So how do we get the minus 1 to the other side? Remember, we have to do the opposite, y'all. What's
We
the
add.
opposite of? We add. And what we do to one side, we do to the.
Other.
Now, if we did the wrong operation, it wouldn't cancel out. Negative 1 plus 0 plus 1 is 0. So that cancels out. So adding 1 was the correct step. 19 plus 1 is 20. And we're done. What questions do we have from these practice problems, y'all, if any? All right. So we have a couple more of these examples, guys. We're almost done with the lecture. Let's go ahead. So I'll give you a minute to set up the first example, and I'm gonna go ahead and work it out, okay? Now remember what you want to do. Draw the line down the equal sign and simplify both sides, and then you manipulate your equation to get x alone, okay? So I'm gonna give you a minute to set this up, and then I'm gonna go ahead and start working them out. Then look at example A. We have 8x minus 9x equals 12 minus 17. Can I combine any like terms on the left side of A?
Yes.
8x minus 9x results to what, ladies and gentlemen?
-1x.
That is correct. On the right side, can I combine any like terms?
Yes.
What's 12 minus 17?
-5.
Now, how do I get x alone? Right now, -1 and x are being what?
Multiplied, so you divide 1x, and then on the other side,
What do we divide by? What goes on the bottom?
the 1x.
Again, no,
one.
what's -1? Because we want to get x alone. So we have to divide what's next to it. So it's just x now. -5 divided by -1. Two negatives make a,
Positive.
and now we check our solution. -40 minus 45 is -5 equals -5, which is true. Now we're going to go ahead and look at B. Can I simplify the left-hand side with any properties we've learned so far?
The
Do the
the 3x times and then the 3 -5.
That's
distributive
correct. The distributive property. Correct, Josh. We are going to multiply by using distributive. So 3 times 3x, y'all. What's 3 times 3x?
9x.
Good. What's 3 times -5?
-15.
-15. Bring down the 10x. Now we just have to manipulate. We just have to manipulate the equation and get x alone. So we have 9x and 10x, but they're on different sides, and we have the 15. How would you get x alone, guys? We want to move x's to one side. So what would you move?
You would add the, I don't know.
Remember, we want
You
now.
got 15.
You want to what?
Change 15 to -15 to a positive.
You have to add 15.
Well, you're only adding it because you want to move it to the right side, right? You want the number to be to the right and the letter to the left. Is that what you're is that what you are trying to accomplish?
Yeah.
So remember,
Yeah.
remember the property. Remember, A equals B is the same thing as B equals A. So you could just do this. 10x equals 9x minus 15. Now it's on the other side. We didn't have to add it. We didn't have to move it. We just flipped it and it's on the right side now. So now that it's on the right side, how do we move the 9x to the other side?
You could do divided by 9x on both sides. and
Now
then
we can't really divide it because
Combine like those.
so what kind of 9 is this? This is a positive 9 or a negative 9?
A positive.
subtract
So
it.
we're gonna have to subtract the 9x. And what we do to one side, we do to the other. This becomes 0. 10x minus 9x is 1x equals -15. And we're done. Now you're probably wondering, well, sir, how do you know you're right? Like, well, remember, y'all know how to check, right? So it'll be check. And it'll be 3 parentheses, 3 parentheses, -15 parentheses, -5 parentheses equals 10 parentheses, -15 question mark. 10 times -15 is -150. 3 times -15 is -45. -45 minus 5 is -50. So then we get 3 times -50, which is -150, which is true. Now you can be more detailed in your checking steps. Like I said, as long as because you remember, we learned how to simplify PEMDAS already, right? So we did the parentheses first, the inside. We did multiply first, 3 and -15. Then we subtracted with the 5, which gave us -50. Then we multiply that with the 3. So we've learned the steps to do this now. Now we're utilizing everything we've learned in this class to help us do the work we're doing now. Is everyone with me so far?
Yes.
All right, let's finish strong, guys. So there's some practice problem. We're running low on time though, just because we've been. Let y'all practice because I need y'all to practice this. I've just seen y'all struggle. I'm gonna give y'all 4 minutes on this one, guys. Good luck. Now we have class until 4:20, y'all, but we will probably dismiss class once we're done with the lecture and answering questions. But remember, if you do have to go, I am uploading the video of the lecture on YouTube after class is over. So just letting you know. All right. Let's talk about the first one, guys. What'd y'all get for the first one?
I don't.
So Ariel and Vicky, you guys got 14. Let's see how we do it. So we draw on the middle sign, on the equal sign,
A negative 14.
negative 14, good. And on the right side, what does that give us? What's 4y minus 5y?
It's negative one
Negative
y.
one.
Negative 1y. And how do we get the negative 1? How do we get y by itself, guys?
Divide by negative one.
What we do to one side, we do to the other. This becomes a big 1, so y is by itself. And two negatives make a positive, so the answer is 14. That's correct. Good job, Ariel. Good job, Vicky. Now look at the second one. What do we do to the second one? What's the first step we have to do? Well, 13x is by itself, right? So what property are we going to apply on the right side?
Multiply the 4 and the 3.
Which is what?
12.
12x. And then is that all we multiply it with, or what else do we do?
No.
Multiply the 4 and the 1.
Which is what?
Negative 4.
And now we get x alone, right? So how do we, what do we move over to the other side?
The 12. You subtract it.
You subtract it. What we do to one side, we do to the
Other.
what's 13 take away 12, y'all?
1. Negative
One.
1. Wait.
Negative or positive?
Oh, positive.
Right, because you have 13 and spend 12, so you still have 1. Bring down the negative 4, and there we go. Now, obviously, you have to check, which is his own process, but everyone okay with the solving part, the steps on manipulating it? All right, let's move on. Now we have another set of examples. I'll go ahead and give you guys a minute to set it up. Let me know when you're done, Alina. All right, on example A, 2x minus 6 equals 18, y'all. I'm gonna go ahead and explain the steps to you guys real quick. So now we're gonna go from having a one-step equation to now multiple steps, all right? Because before it was just like x plus 5 equals 10, subtract 5, boom, we have x. Now that's not the case anymore. Now we're gonna have a little bit more challenging to our equation here. Now remember, the goal of solving an equation is manipulating it to get x by itself. So 2x minus 6. We can't combine those because they are not like terms, but we could move the minus 6 to the other side. How do we manipulate the equation to get minus 6 to the other side? Anyone help me out?
Plus 6.
Plus 6. And what we do to one side, we do to the other. This becomes 0, bring down the 2x equals and add 18 and 6, which gives us 24. Now we're not done because x is not alone yet, but we know what's happening here, right? So what do we do next?
Divide by 2.
Divide by 2. Excellent, Melanie. So then we get x equals, this is a 1, right? 24 divided by 2 is?
12.
And we're done. Now, obviously, we do have to check, right? Because we want to make sure we're good. So I'm going to show you real quick how to check. So that will be 2 parentheses 12 minus 6 equals 18 question mark. 2 times 12 is 24 minus 6 equals 18, which is 18 equals 18, and it's true. So we are correct. Do not get intimidated by these checking, guys. Don't get turned off. Don't say it's too much work. This work is meant to exercise your brain to see, are you reasoning with yourself with these values? Now, I know B goes from 0 to 100, so let's break it down together. Draw the line on the equal sign. Can I simplify the left side, y'all? Yes or no, and how?
Yes, you can do 2 minus 6.
And what do y'all get?
4. -4.
Anyone agree or disagree with this?
I agree. I got -4.
Excellent. Now on the right side, y'all, we're gonna have to do some simplifying, right? But what property do we have to do first to get the simplification started?
Distributive property.
Distribute. What are we gonna distribute?
The 5, so 5 would be -5x,
And then for the second arrow,
20 plus
Okay.
20.
plus 20. Anyone agree, disagree?
Would it be -20?
It'll be -20 because one's negative and one's positive. Now, do I have any like terms on the right side I can combine?
Yes, the 20 and the 39.
If you owe me $20 and you borrowed 39 more, how much do you now owe me?
Negative 19. Oh, you
bor-
add it. You
Ye-
add it.
Yep,
-59.
that's correct. Now we have to solve for X, guys. So what do you move first to get X alone?
So 59.
Plus 59. What we do to one side, we do to the.
There.
If you owed me $4, but you have 59 in your wallet, after you give me the 4, you're left with how much?
-63 or +63. Oh, I don't know.
Well, you gave me $4 though, so you have more money than what you started with. If you gave me $4,
Well, I got 55.
55.
it's 55. Do you see that?
Yes.
Okay, equals -5x. Now, how do we get X alone, y'all?
Divide.
Divide by -5.
Good. And then how many -5s go to 55?
11. A -11.
Correct. And we're done. Now, I am not going to check this one because that's going to be a little messy, but I'm just going to do it quickly on top here just to show you that it works. So check, right? 2 minus 6 is -4. So we know this is 4. -4 equals question mark. -5 parentheses, -11 plus 4 minus 39. Well, -11 plus 4 is -7. -7 times -5 is +35. +35 minus 39 is -4. So it's true, guys. And you guys should work on this on your own, the checking. Make sure you guys are able to make sure you have the right answer or not. It would be a great resource for you to have on the exam because we are going to have some equations on the first test. Any questions so far on this example?
No.
All right. Here's another set of practice problems, guys. There's 2 of them. I'm gonna go ahead and give you 4 minutes again, guys. Good luck. All right, guys. Anyone want to talk about what they got and if there's any disagreements for A or B? Let's go with A first. What do y'all get for A? I see y equals 5 and y equals 3. What do y'all think, guys? Is it 3 or 5?
It's 3.
Okay, so you're good,
I
Melanie?
got 3.
Okay, cool. Anyone need me to explain A before I move on to B? Y is 3. But anyone need me to explain it before I move on to B? All right, let's look at B. What did y'all get for B? I'm seeing they're negative 13,
Negative 15.
negative 15, and negative 17. Ooh, those are all odd numbers. Let's see how, okay. How'd y'all get it? So what's 2 minus 10?
Minus 10 equals -8.
Yep. Bring down, now we distribute the 4, right? So what's negative 4 times X?
-4 minus 8.
Negative 4X minus 8, good, minus 60. Now, do we have any like terms here that we can combine, y'all?
The 8 minus 60.
What do you get when you combine those two?
I got 60. I got -68.
That's correct. Now, to get X alone, what did you do to manipulate it?
Divide by 4.
You sure? Remember, you can't divide yet because you have extra baggage here. We have
Oh.
to, so we move that first. How do we move that first? How do we move negative 68 to the other side, y'all?
Add 60.
Divide.
Subtract 60 on the other, yeah.
Well, it's already being subtracted, so we have to do the opposite, which is what?
Add.
We have to add it. And then you owe me $8, but you have 68 in your account. After you send me the 8, how much do you have for yourself? 60. And now to get X alone, how do we move that negative 4?
You divide it on both sides.
That's correct. And what's 60 divided by negative 4?
Positive 15.
There you go. Everyone see how it's negative 15?
Yes.
Excellent, guys. Any questions before we move on, guys? Are y'all catching your mistakes on where you're making little mistakes on? That way you can avoid that in the homework?
Yeah.
Okay, good. Awesome. All right, we're almost done, guys. The final few lessons, the final examples, all right? So you don't have to write the first part of the example. You just got to write example 9. Because we already have this written into our journal, right? Top part already. But I put it up to just show you, hey, even though we did it in another section, we're still using it in a later section. That's what's so beautiful about mathematics, is that it's so connected. So for next class or next week, I want you guys to make this box into a note card. So that way you can reference this as you're working on this class this semester. The last question, my bad, Alina, let me show you. It was negative 15, man. Negative 15. You're talking about the practice, right? Okay, cool. Negative 15. And if you want me to go back to the work, I can go back after this example. If you want me to, just let me know. Or at the end of the lecture, because we're almost done. All right, since we've already done problems like this, I want you to try to, after you write the example, I'm gonna give you 2 minutes. I want you to start working them out. Can you write an expression from words? That's a big skill set that's gonna help you in this class, especially for this first test and stuff, because you are gonna see a handful of these problems on the exam.
Mr. Pacheco, how much longer of class do we have?
Class, well, I was gonna dismiss once I'm done with this lesson and answering questions about the rest of the week. But if we were to follow the entire time, we would actually stay online till 4:20. But my goal is to only utilize up to 4:20 if we need to.
Okay.
But yeah, for anyone who's wondering, class is until 4:20, but I will dismiss early depending on the day and what we have going on.
If we have to leave early, can we watch it like in later?
Yes, of course. If you have to go, you're welcome to go as long as you make sure you finish the lecture on YouTube once you have the time.
Okay.
And I recommend to do it before Wednesday's class, so that way you're not like, wait, what? Because everything's always building onto each other. If you notice that, okay? All right, guys, let's look at 9A. So we're gonna write each phrase as an algebraic expression. We use X to represent a number. So a number increased by -5. So since it starts with the phrase a number, what letter do I draw first?
X.
Good, and it's increased by, so what operation is increased by?
Addition.
Addition.
Plus, and what are we increasing by?
-5.
-5.
Good. Now look, we have a plus, a negative. Is that correct? Can we have that in math?
No, yes.
Yes, we can, but it's not really pretty. It's not really standard. So we can combine them to make what operation overall?
Multiplication.
Plus a negative is a times. So it'll be X times 5, or what do you mean? Because plus a negative, it makes a symbol. It's either going to be a plus symbol or a minus symbol.
A plus.
Think about it. Yeah, look at the signs. You actually look at the little chart that I made you write last week. It's
A
not
negative.
a negative. So it'll be X minus 5. So X plus a negative number is just the same thing as X minus that number. These mean the same thing. And I want you to make sure you know that, okay? B. B is the product of -7 and a number, right? So what operation is product?
Multiplication.
Multiplication. So what are we going to be multiplying? We're multiplying -7 with what?
You're gonna do -7 times X.
Yep. And which is just the same thing as -7x. So they mean the same thing. C, a number less 20. So since it starts with a number, what letter?
X.
X.
But it's less is 20. So what operation is less?
Minus.
So minus 20. So we're done with C. D, the quotient of -18 in a number. So what operation is quotient?
Division.
Division.
What should go first?
X.
You sure? What's first in the word?
-18.
So it'll be -18 divided by X, or and I want you to start doing the fraction version of instead, okay? Because this is like this is college appropriate. So we don't really use the other division symbol often anymore, really. All right, and then we have E. Be careful with E, it's a tricky one. A number subtracted from -2.
X minus or X. Yeah, X minus 2. X minus -2.
Read it again logically. Does that make sense that we're going to subtract?
A number. So it's going to be X.
Now,
Is it gonna be -2 minus X?
what was the key word that makes you change that? What was it?
I've got subtraction.
It is subtraction, but why did you put -2 first? Because what's the one word that makes you realize that -2 goes first?
Oh, it's asking from -2, then the number.
So it's gonna be -2 minus x. We're subtracting that number we don't know from -2. So -2 has to be first because of that word from. Does that make sense, ladies and gentlemen?
Yeah.
All right. Are you ready for your first practice problems on these? Well, not your first one, you know. Good, Elisa. I see your comment. I'm glad you see that, man. So let's see how you guys do on the practice. Ready? I'm gonna go ahead and give you guys 4 minutes. Let me know when you're good, Ariel. All right, let's look at A. A is the sum of -3 and a number. So how would you write that?
I got x plus 3.
Okay. Now be careful with the digit. You said x plus 3, but what is the sum? What are you really finding the sum of? What
Negative
two?
3.
-3. So you could say -3 plus x, or if we wanted to switch the order from the commutative property, we could say x plus -3, but we don't really say plus negative, right? Which is just x minus 3. Any of these is okay for you to say.
But we
So
can write those just in case it was on the test or something.
that is
Either
correct.
way, okay.
Yep. And everyone follows with me how they are all similar though, right? Everyone sees the same,
Yeah.
especially from the properties that we learned. B, what did y'all get for B?
-5 minus x.
Anyone agree or disagree? All right, so let's put x minus 5. Now, if you wanted to switch the order, now this doesn't really work because it's a subtraction. So this one is -5. You gotta make sure you break it down, Alyssa. So it's saying that -5 is being decreased by a number. So since -5 is decreasing, then we're gonna subtract from it. Does that make sense? We're gonna go lower, right? By whatever this is, which is x. If it said a number decreased by -5 would be, or decreased by 5 is your method. What you wrote x minus 5. It would be a number decreased by 5, but it's not the case here. Look at C. C says 3 times the number.
I put x times 3.
X times 3. Okay, you're not wrong, but what does x times 3 simplify to?
3 times x.
3 times x, which is just 3x.
What about if I put x3? Is that the same thing or no? No?
Not really. So
Okay.
you could say it, but this is not formal. This is the formal one. You want the
Okay.
coefficient first, okay?
Okay.
Now don't let these surprise you or shock you. A number subtracted from 83.
83 minus x.
That's correct. Just because of that keyword there. And then E, what did y'all get for E? Now give me just a fraction of E though. Don't give me the elementary algebra division. Give me the fraction.
4.
What over what?
-4, x over -4.
X over -4. Is that what you said, Melanie?
Yes.
Excellent. All right. Good. All right. Does anyone need more time to copy this down before I move on? We're almost done, guys. All right. So this is the last example, y'all. The last example. Now it's the same thing as before as example 9, but the thing is now adding multiple things is happening now. Like the other thing was just like x plus this, x minus this. Now it's multiple operations happening. So I'm gonna give you about 2 minutes to write these down. Then I'm gonna start working them out, okay? Now, if you finish these and want to try them on your own, go ahead until the timer runs out, then I'll start, but do what you want. But I am going to work these out for you. All right, guys. So let's talk about example 10. So write each phrase as an algebraic expression. Let x be the unknown number. Let's look at A. Twice a number increased by -9. What does twice a number mean? When we twice something, we're gonna multiply it, right? So and then a number, so it's twice the number, so it'll be 2x. 2 times x is twice the number. Everyone with me on that? It's being increased by -9, so we're gonna add -9. But remember, we can have a plus and a minus, so that some combines into a minus sign, so 2x minus 9. Does everyone follow how we got A? Twice a number increased by -9. Let's look at B. 3 times the difference of a number and 11. So it's 3 times. So 3 times. So we're multiplying, right? The difference of a number and 11. What operation is difference, y'all?
Subtraction.
So we're gonna subtract x minus 11. We're gonna get that difference and we're gonna multiply it by 3. Does everyone see how we got this?
Yeah.
All right, C. The quotient of 5 times a number and x. So we're dividing, but what's gonna be on top? 5 times the what? What's 5 times the number? What is that expression gonna say?
Divided by
5x divided by what?
17.
Yep, and we're done.
I have a question on the first
up?
on A, you put 2 times x, right? And then plus, that's that little thing right there in between is a dot, right?
Right here?
Yes.
Yeah,
there
I
it is.
did that because of this phrase here, but remember that a number next to parentheses is also multiplication. So you don't
Yeah.
have to put the dot there. This is enough.
Okay.
Great question, by the way. Everyone remember that how a number with parentheses is also multiplication? All right. Now I don't want to baby y'all, so we have last set of practice and we're done for today's lecture. You guys ready for it? It's similar to these examples. Any questions before I move to the next slide? Is anyone still writing? All right, let me know when you're done, Ariel. And I'm not trying to rush you. I'm just making sure I'm not letting y'all miss notes and stuff. And my apologies if I'm going a little quicker. I just want to make sure I don't bleed after 4:20. Let me know when you're done.
She's done.
Thank you. All right, guys, last practice problems of the lesson and we're done. As you guys are working through these practice problems, do y'all notice how there's multiple operations going on now? So do not get overwhelmed. Look at it piece by piece and try to piece it together. And then read the expression aloud to make sure it satisfies what you read in the problem, okay? So let's see. I'm excited to see what you guys got for these answers. You can feel free to type them in the chat or feel free to unmute and let me in the class know.
I think I did A wrong. I did 5x minus 25.
Does anyone want to talk about what they got? Did they get the same thing as Jennifer or something different? Well, let's talk about it, Jennifer. The product of 5 and a number. So we know product is what operation?
Multiplication.
And it's between 5 and a number where we know x is the number, right? So
Yeah.
5x, you're right on that part. And it says it's being decreased by what?
45.
Which is what operation?
Subtraction.
And you're good, ma'am. You actually got it right. Good job.
Oh. And then for B, would it be 2x plus? Oh, no, would it right?
You said 2x plus what?
3?
So the way you would write this in words, it would say twice the number. So it would be the sum of twice the number and 3. That's what this would be. This is the sum of twice a number and 3. That's not what it says here. So this is
2 plus 3x?
Say that one more time.
2 plus 3x?
So this is the sum of 2 and 3 times the number.
Oh.
So keep throwing your ideas out there. You want to make sense of this. You want to see. So look at what I do. So what does this say?
Twice.
So we know it's going to be a number. What number?
2.
2
And when we twice something, what operation are we going to do?
Multiplication.
x. Oh,
Would it be 2 times x plus 3?
It would
Well,
be x plus 3.
what was that?
3 parentheses x plus 3.
Woo! Get it, Melanie. Go buy a scratch off, girl. Yeah, 2x plus 3. Do y'all see why the x plus 3 is in some parentheses?
Yes.
Because we're twicing the what? What are we twicing?
the sum.
Of what?
A number.
And 3.
Twice the sum. Sum.
So if it said this, if it said twice the number, if it said the sum of twice the number and 3, that is what you first said, Jennifer, 2x plus 3. All right. Yeah. Does that make sense? You see the difference of the wording, how it says twice the sum. So we had
Yeah.
to twice an addition problem. Okay. Now C, the quotient of 39 twice a number. So what's on top and what's on bottom, y'all?
39 divided by 2x.
39 divided by 2x. And that is correct. Everyone understand how we did the quotient part? The first thing goes on top. The bottom is the second part is the bottom. And you guys just finished 2 sections of elementary algebra. How does everyone feel today? Whew, that was tough, right?
My brain is mushed.
Yeah. yeah, sounds about right. I'm sure your brains feel smooshy, your hands feel sore. I can